The question is, evaluate the value of integration of this function x into log x whole square. Now to solve this question, first of all, we observe the given integral and we see that it is the product of two functions. One is x, second is log x whole square. Now we cannot integrate log x whole square directly. Okay, we can integrate x. We can differentiate both the functions. So the logic here is this: because we cannot integrate log of x whole square directly, or it is not possible to integrate, so we are going to take log x whole square as the first function and x as the second function. So I'm going to get this as equal to log x whole square into x. That is, log x whole square is my first function and x is my second function. Okay, now I'm going to apply the formula of integration by parts. Okay, there is a formula written for reference, and on applying the formula I'm going to get this as first function into integration of second function, that is log x whole square into integration of x, minus differentiation of log x whole square into integration of x, and the integration of the product of the terms inside the bracket. Okay, now the integration of x would be x square upon 2. Okay, this will be x square upon 2, and differentiation of log x whole square would be 2 log x. First of all, we are going to apply here the chain rule. Therefore, according to it, this will be 2 log x into d upon dx of log x, that will be 1 upon x. So I can write, so we are going to get on differentiation and integration of these terms as log x whole square into x square upon 2 minus 2 log x upon x into x square upon 2. Okay, this x and this power cancels out, this 2 and this 2 cancels out, so I can write this further as 1 by 2 x square log x whole square minus integration of x log x. So on simplifying this bracket, I get again the term which contains the product of two functions. So to solve it, I have no option rather than to apply the formula of integration by parts again. Okay, so I'm going to take again the log x as first function and x as the second function and apply the formula of integration by parts. So I'm going to write this as this term, the first term as it is. So inside the bracket, I'm going to write this as log x into integration of x minus differentiation of log x integration of x and whole integration. So you see that I've taken log x as the first function and x as the second function, similar to what I have started. Okay, so you can make it a point that if we have been given an algebraic and a logarithmic function, then you have to take algebraic as the first function. You have to take log x as the first function and algebraic as the second function. Okay, now on integrating x, I'm going to get x square upon 2. Differentiation of log x would be 1 upon x, and here also integration of x would be x square upon 2. So I'm going to get this as 1 by 2 x square log x whole square minus log x into x square upon 2 minus integration of 1 upon x into x square upon 2. On simplifying these terms, 1 by 2 into x square upon 2, that is cancelling x with this power, I'm going to get 1 by 2 x square log x whole square minus log x into x square upon 2 minus x upon 2. Okay, now we have to just integrate this term x square upon 2. So 1 by 2 can be taken as constant and integration of x would be x square upon 2. So I'm going to get this as 1 by 2 x square log x whole square minus log x into x square upon 2 minus 1 by 2 into 1 by 2 x square. And simplifying the bracket, I'm going to get the answer. So this will be equal to 1 by 2 x squared log x whole square minus 1 by 2 x squared log x plus 1 by 4 x squared plus c, which is my required answer. Thank you. Please support us by subscribing to our channel, by liking this video and giving your comment for the video.